For decades, the internet has operated on a single assumption, that more raw data leads to better intelligence. This has sparked a global race to capture every digital footprint, hoarding information in massive, siloed server farms in the hope that a perfect reality will eventually emerge. But there is a mathematical ceiling to this approach. Global systems today can only partially reconcile about 14% of the population. This 14% fragmentation limit is a hard barrier. Top-down systems struggle to identify anything outside their own narrow administrative categories. This leaves the remaining 86% of the world largely invisible to the core institutions that govern finance and energy. Billions of workers in informal economies exist in a data blind spot, operating entirely outside the reach of legacy networks. Because legacy systems cannot see these individuals, they rely on statistical ghosts. They make trillion-dollar decisions based on systemic averages, like the theoretical 2.3-person household, rather than the actual living ground truth of the people they serve. This is a paradox that data collection cannot solve. Macro institutions remain inefficient because the data they use is an approximation. To fix the system, we have to bridge the gap between these top-down averages and the fragmented realities at the edge of the network. These bad assumptions carry a heavy price. Trillions of dollars are currently locked up in defensive capital, money set aside by corporations and cities to hedge against the risks created by their own lack of accurate data. We see this waste in 80% failure rates for new products and massive interconnection queues where grids are stalled by phantom demand. Money that could be productive is instead held in reserve to cover bad debt and inefficient compliance. The Sovereignty Engine, or ZIP-001, is a protocol designed to upgrade the Internet's architecture to solve this. It introduces a third layer to the network, specifically for coordinating sovereign data. Its core design is built on a simple rule: query, not collect. Instead of pulling data out of its source and into a central database, the system sends questions to the data where it already lives. By focusing on truth attestation rather than collection, the protocol removes the need for expensive defensive guesswork, allowing systems to operate with actual certainty for the first time. When an enterprise verifies a fact, the request routes through the social helix. This architecture translates the question into a secure hash, protecting privacy from the start. This query arrives at the individual's personal device, specifically within a sovereign engine called the countermirror. This requires a human to stay in the loop. The device compares the network's question against local, encrypted information and asks the user to confirm the result. The individual sees exactly what is asked before any response is sent. If confirmed, the device generates a zero-knowledge proof, a mathematical signature proving the answer without revealing personal data. The raw information never leaves the device. This mechanism severs the old link between verification and surveillance. Institutions get the certainty they need, but the individual retains absolute custody of their private life. One individual's word isn't enough. The protocol cross-validates these proofs against the dynamic tensor moat, a grid of sensors, consensus, and ledgers. Once 67% agree, the network achieves a tensor lock, creating a scalar digital twin, a real-time, highly accurate representation of truth at that coordinate. Because this verified pattern is now recorded on an immutable ledger, the raw, temporary data used to find the answer becomes useless. This solves a massive liability for modern organizations. Since they can now rely on the verified pattern, they can finally destroy their hoarded hot data lakes, removing the risk of future leaks and regulatory fines. When we remove the friction of inaccurate data, the trillions previously locked away as defensive capital are finally released. Stagnant reserves for bad debt and inefficient compliance become fluid capital that can flow back into the economy. The protocol sustains itself on a maximum 8% of this flow, ensuring it remains a utility. The remaining 92% routes back to origin points, to individuals as recovered time, and enterprises as operational capital. Consider the impact of removing the 60% inflation in customer acquisition or clearing the 80% waste in interconnection queues. By replacing these massive systemic failures with verified truth, the network generates a 36-to-1 efficiency dividend. meaning every dollar of defensive cost removed yields $36 of productive growth. This efficiency makes the sovereign Layer 3 network mathematically cheaper than staying in today's fragmented silos. It isn't just about privacy. It's about the massive economic advantage of working with certainty. The network reaches its native pattern phase when it hits a critical mass of 67% adoption. We don't need 100% adoption for the system to work. Once 67% of the network is coordinated, the sheer cost savings and efficiency make it impossible for the remaining third to stay outside. The transition becomes organic. To protect this system for the long term, the protocol is governed by 37 constitutional locks. These are immutable rules built into the code that no single entity can change. These locks protect essential boundaries, guaranteeing that no node can be forced to disclose its private keys, and ensuring that future generations always have a protected floor of equity in the system's growth. ZIP 001 functions as the essential global plumbing for a world that needs both advanced technology and human sovereignty. It ensures that as our data becomes more powerful, our control over it scales at the